Consider the parallelogram below. First thing we want to do is show that triangle ADE is congruent to triangle CBE, and hence show that AE is equal to EC. So let's think about the triangles. We've got ADE, which is this triangle here, and we want to show that that's the same as CBE, which is this triangle just here. We want to show that those are congruent. Now this will be a very long example if I go through too many of the steps here. In the previous example, we already demonstrated that the opposite sides are equal in length. So we have that fact. So we can start here by saying that AD is equal to BC. And I'm just going to put here proven, as we did that in the previous example. Now, we can show that this angle is equal to this angle. Once again, it's a Z shape with the parallel lines, so they're alternate angles. So we can say that angle DAE is equal to angle BCE, and that's alternate angles. And then we could also show that these angles are equal, again using alternate angles, the Z shape as we saw in the previous example. So that's angle ADE is equal to angle CBE. And therefore the triangles that we said ADE are the same as triangle CBE. We use two angles on the side, so that's ASA or AAS, however you're used to writing that one. And then we can say, well, AE is equal to EC. So if we think about those, AE and EC, they are equal because they are corresponding sides in those two triangles, in that they go between the green marked angle and the third angle there, which I could maybe mark in pink. Note that I used alternate angle twice there, but we could have shown that these two angles were the same using vertically opposite. And indeed, why don't we do that in the second part of the question? Because in the second part of the question, what we're being asked to do is show that two other triangles are equal. And the two triangles that we're being asked to show this time are this one at the top and this one at the bottom. Let's go through this a bit more quickly, and I'm going to do it up here so I don't have to scroll. So we could start with these two angles, and we could say angle AEB is equal to angle DEC, and those ones are vertically opposite. As I said, I could have used vertically opposite earlier as well. And then we could go for angle, let's say that we're going to show that this angle is the same as this angle. So we'll say that EBA is the same as angle EDC. And that's alternate angles. We can see it's on a Z shape with the parallel lines. And we can also say that AB is equal to CD, and that was proven in the previous example. And therefore the triangles ABE and CBE are congruent. And again, I've used AAS, 2 angles and a side. And then, once we know that is the case, we know that these sides correspond. And so BE is equal to ED. Which is corresponding sides. The question is, what have we shown? So if we go back to our diagram, well, what we did show was that these two things were equal in length. And we also showed that these were equal in length. So we showed that the diagonals bisect each other.